Okay, guys, there is a lot going on in these two sections. The course covers difference identities and then it covers some identities, but there's a lot going on here. So we're going to start with difference. They actually do a job of proving the difference formulas. They also bring up the cofunctions and things like that. But what we're going to do is we are going to work on a couple of things. So, the very first thing that we're going to do is we're going to work on just proving an identity. Okay. Okay. And then we're going to solve equations. Okay. And we're actually going to use both the sum and the difference. Okay, so let's go over the sum and difference formulas for sine, cosine, and tangent. Okay, so let's start with the sine. All right, so here we go. Okay, there's the sum identity, and here's the difference identity. Now, what I want you to notice with this one is sine and cosine switch, they take turns. Okay, also that the sign itself is preserved. So if you have a sum on the left hand side, you have a sum on the right hand side. If you have a difference on your left hand side, you also have a difference on your right hand side. Cosine is a little bit different. All right, so if we have cosine of x plus y, the right side will look like cosine x, whoops, cosine x, cosine y. Then the sign in the middle will change to the opposite, and then sine goes next. Opposite. Okay. Now, tangent, to me, tangent was always a little bit harder to use because it's just a little bit more complicated than sine and cosine, but we'll go ahead and we'll write those down. Okay, there's tangent. There is. Now, notice how they almost look exactly the same, except for the signs. Okay, when you have a minus sign, you have a minus then a plus, minus on the top, plus on the bottom. We have a plus sign, plus on the top, minus on the bottom. Okay, so what we're going to do, okay, is we are going to work on proving some identities. Now, I pulled some identities that are not in Edgenuity. Okay, so when you're proving an identity, you're actually proving equality. So you don't know if the two things are equal, okay? So if you don't know that the two sides are equal, you can't move stuff from the left to the right and the right to the left. Okay? Because those all have to do with properties of equality. And if you don't know that something's equal, you can't use the properties of equality. Okay? So no moving stuff. Okay, you can work one side, but not move it to the other side. Okay? So let's try one out. Okay, so I have cosine x plus y times cosine x minus y. And I want to prove that that is equal to cosine squared x minus sine squared y. Okay, so you have two options. You can work the left side, you can work the right side by themselves, or you can work both sides at the same time. You just can't move things from the left to the right. So what I'm going to do is I'm going to work on the left-hand side. And what you will notice is that I'm still using the rules of algebra. I'm distributing, I'm multiplying, I'm combining like terms, things like that. I'm also bringing in the identities that I have up at the top. I'm not breaking any rules, nor am I making some stuff up. I'm following all the rules of math. It's going to look messy, it's going to look complicated, but I am not breaking any rules. So the first thing I'm going to do is I'm going to rewrite these two guys in terms of their identities. Okay. So cosine x plus y is equal to, oops, cosine x cosine y minus sine x sine y. Okay, that was the first one. So times cosine x minus y like that. And that's just the left side. So now I'm going to sit there and kind of think, okay, what does this look like? I see two sets of parentheses. They have stuff added and subtracted. So my instincts tell me that this is a distribution problem. Okay, so I'm going to go like this. Again, it's going to look messy, and that's okay. All right, so cosine x times cosine y times cosine x cosine y. Well, I'm just going to glue them together. Okay, now I have cosine x times cosine y times positive sine x sine y. Okay, let's glue those together. Positive times a positive is always a positive. Okay, now I'm going to go on the other way. So negative sine x sine y, cosine x cosine y. Okay, now I'm going to go negative sine x sine y times a positive sine x sine y. So that would be a negative. Oops. All right, now we're going to look for things that I can simplify. So if you look at these two guys, they're exactly the same, except they're the opposite sign. So these will actually go to 0 when you combine them. Okay, now these two guys, I can rewrite those because I have cosine x, that's cosine squared x, cosine y, cosine squared y. Okay? And the same thing for this one over here. So that goes to 0, remember. Now what we're going to do is we're going to stop. Okay? And we're going to see what we have. Okay? Are we any closer to the right-hand side? Well, now what I have is I have cosine squared x minus, or times cosine squared y, minus sine squared x sine squared y. So I'm almost there. Okay? This, believe it or not, is a difference of two squares. I can factor that. So let's see where that gets us. Did that get us anywhere? No, it really didn't, did it? Well, I might have to try something new. Okay? So that didn't help. And sometimes you do run into that where you try something and it doesn't work out. Notice this didn't, it just brought me backwards. So I'm going to go ahead and erase that. Okay. So now, what do I want to get rid of? What do I want to keep? I want to keep the cosine squared x, and I kind of want to get rid of the cosine squared y. So, if I recall, this identity right here, oops, should be x. Okay, I can rewrite that. So instead of writing x, I can write y. I can also rearrange. Okay, so I want to keep my cosine, I want to get rid of sine y, so let's try substituting. Okay, now notice I want to keep the sine squared y, so let's do the same thing, but let's do it with the sine squared x. Getting a little creative here, and that's okay. I always thought that these were kind of fun because what it does is it kind of allows you to kind of play around with the math. Okay, so you got to be careful here because you got a lot going on. So let's go ahead and distribute again. And again, we're just seeing what happens. Then we gotta be careful with that negative. Okay, so now I got that. So let's take that negative. Let's see what happens. Oops. Distribute your negative. Okay, now check this out. These two guys are the same, but they're opposite signs. So what happens? They go to 0. So those will go to 0, and you're left with this. Oop, messed up. Check that out. Look at that. It's exactly what you wanted. Now your right side matches your left side. So this was a whole lot of algebra here, right? Notice that we just worked that left-hand side and we got to match the right-hand side. And we're done, okay? All right, so that's how you work an identity. Okay. So let's try to work another one. Let's work something a little bit simpler. Okay. All right, so let's say I have cosine of 5 pi over 4 minus x is equal to negative radical 2 over 2 times cosine x plus sine x. Okay, so now I'm going to work the left-hand side, even though it looks a little simpler than my right-hand side, because there's more stuff to work with because I have that sum and difference identity. So what I'm going to do is I'm going to look at my difference identity for cosine. So I'm going to go cosine 5 pi over 4 cosine x plus sine 5 pi over 4 sine x. Okay, so again, working the left side. So consulting your unit circle or your calculator, what the heck is cosine of 5 pi over 4? That would be negative radical 2 over 2. Okay, times cosine x plus, then again, negative radical 2 over 2 sine x. Hey, look, I can factor that out. And now my left-hand side matches my right-hand side. Okay? All right. So our next video will be working with equations.